Thinking is not always accurate, but in decision-making, thinking is a process of reducing uncertainty in the accuracy of conclusions, which reduces mistakes in decisions. In the video on judgment, I briefly introduced the idea that most errors in judgment occur as a result of how people choose to handle uncertainty. And people have several options for how they choose to handle uncertainty. They could rely on what is known and suspend judgment about what is unknown, or they could speculate, use mental logic, or form beliefs about those unknowns. When people choose the second option, they tend to draw inaccurate conclusions that sometimes lead to harmful or costly consequences. People also have a third option in how they choose to handle uncertainty, and that is to acquire more information. Sometimes you need more information to have confidence in the accuracy of a conclusion, and that's where thinking skills come into play. Most mistakes are made not because of a lack of information. They're made because of a lack of effort to obtain that information, which then creates uncertainty. But it's possible to improve the accuracy of thinking when acquiring that information by practicing some simple techniques. First of all, if you want to draw accurate conclusions, rely on the highest quality information available. High-quality information is information that is truthful, complete, and accurate. Low-quality information, in contrast, is very incomplete and inaccurate and leads to wrong conclusions. In my video on judgment, I also looked at how the human brain is incapable of constructing an accurate model of reality. The model it creates contains missing or inaccurate details, so those mental models are low-quality information. An exception to this would be a person who is a subject matter expert. That person may have enough information or may know how to acquire that information to avoid common pitfalls. But usually any conclusions based on mental creations such as logic, probability, or beliefs are factually incorrect. The reason people believe misinformation essentially boils down to bad judgment. It's a failure to adequately distinguish between what is known and not known. And instead, the individual relies on rumors from social media, their own beliefs and logic, or their favorite podcast host. Some people follow the notion that if other people are doing something or believing something, it must be for a good reason. And many other reasons exist for why people use bad judgment and believe misinformation. So ideally, one would rely on the truth to prevent wrong conclusions and potentially harmful or costly mistakes. But what exactly is the truth with a capital T? And can the truth actually be known? The truth is a quality of information. When information is said to be true, it accurately describes reality. And when information is said to be untrue or false, it doesn't accurately describe reality. When the human brain constructs a model of reality, that model is not an accurate representation of reality. It has missing or inaccurate details that sometimes lead to wrong conclusions. So mental creations, including assumptions, speculation, or beliefs, never accurately describe reality and are more likely to contribute to mistakes. The truth is also considered interchangeable with reality, since information that is true accurately describes reality. But sometimes the truth is difficult to believe or hard to comprehend. Sometimes the truth is imprecise and can only be approximated. Sometimes the truth needs to be researched and fact-checked to confirm its accuracy. And sometimes the truth is an ideal to strive for, to be an honest and credible person. Information that is proven to be true with some degree of accuracy is called knowledge, and knowledge is usually derived from facts and data. Scientific facts, for example, are expected to be replicable, predictable, and describe fundamental truths about nature. At standard atmospheric pressure, water boils at 100 degrees Celsius and freezes at 0 degrees Celsius. These facts remain consistent and reproducible at standard atmospheric pressure, no matter how many times they are tested. Because science seeks to discover the truth about natural phenomena, it can also be one of the best sources of high-quality information. However, not everything with a stamp of science is true. An example would be a business startup that makes false or exaggerated claims about their products to attract venture capital funding. But science is still one of the best sources of high-quality information. That mostly has to do with the fact that nature and objective reality are not simple and intuitive to understand, but science can understand and extract that truth by using a systematic process. When using the scientific method, for example, the scientist starts with a hypothesis, which is an unproven prediction or mental model about how something works. Then, the scientist creates an experiment to test the validity of that prediction. instead of making intuitive guesses or subjective interpretations about the nature of reality. The scientist relies on the results of testing and experimentation to reveal the truth. Those findings can then be challenged and scrutinized by other scientists to confirm or disprove their validity. High-quality information is not always difficult to obtain. Sometimes it can be obtained by using common sense, such as your eyes, ears, and brain. This seems relatively simple and intuitive. However, many people make assumptions, do research, or believe hearsay when all they have to do is use their eyes, ears, and the obvious facts to draw a more accurate conclusion. Reducing things down to numbers can also improve the accuracy of conclusions. Examples include measuring physical dimensions to create accurate estimates for a construction project, or tracking expenditures to ensure the profitability of a business. Other times, high-quality information may be more expensive to obtain, such as when it involves highly specialized subjects. In those circumstances, experts can provide advice or services to avoid common pitfalls and reduce harmful or costly mistakes. In many circumstances, if a government official or a business owner neglected to rely on expertise, they could lose millions of dollars due to making easily preventable mistakes. Problem-solving skills reduce uncertainty about the cause of a problem. Having good problem-solving skills is important because sometimes people handle their problems poorly or avoid them altogether. And perhaps nearly all problems that plague modern societies are measurable and reducible with effective policies and programs. A common problem-solving technique is the process of elimination, which tests for factors known to contribute to a problem in the attempt to identify the cause. This is similar to a scientist creating a hypothesis and then testing that hypothesis to confirm its validity. Suppose Zane is a robot mechanic. This morning, his manager drops off an inoperable robot. As the expert, Zane knows the function of each part, and he quickly identifies a few parts that may be responsible for the failure. So he replaces each part, starting with the most likely, least destructive, or least expensive. Eventually, after replacing a specific part, the robot starts working again, and through the process of elimination, Zane has fixed the robot. Modeling techniques are also helpful for reducing uncertainty in conclusions. Examples include mathematical models, scenario analysis, drawings, diagrams, prototypes, artificial intelligence, reality testing, or simply using your imagination. Being able to model ideas helps the creator to scrutinize the details, find flaws, and make corrections before building out the project. Failing to do that may lead to spending twice as much time and money on do-overs or scrapping the project altogether. Today, artificial intelligence helps scientists to model natural phenomena to reduce uncertainty in their conclusions. One example is AlphaFold, an AI system created by Nobel Prize winners John Jumper and Demis Hassabis. AlphaFold simulates protein folding and predicts protein structures from their amino acid sequences. Doing this manually is very time-consuming and takes several years. AlphaFold is able to perform the same task in seconds. And since its release, it analyzed over 2 million protein structures and made them available to the public. The project also discovered a solution to a 50-year-old challenge in biology to understand protein folding down to atomic accuracy. AlphaFold enables scientists to perform experiments that would be impossible using real protein structures. And today, it helps scientists to find cures for diseases and to answer other mysterious questions about microbiology. In recent decades, the cost of high-quality information to consumers has dramatically declined due to internet access and artificial intelligence. However, it may still be necessary to verify the accuracy of information and fact-check with credible information sources to ensure the accuracy of your conclusions. Thank you for watching this video. These topics and many more can be found in my recent book entitled Decision-Making Skills, a guide to handling uncertainty, driving results, and cultivating well-being.